All right, looking at section 3.1, the main theme here is determining distance and midpoint given any pair of coordinates, but they throw in some application with triangles. So we're going to do one problem that's going to sum up all of these things in one. So in this example, we're given three coordinates. We have 2, -7, -3, -1, and 7, -1. And we're first asked to determine, is this a right triangle, an isosceles triangle, or is it scaling? So to determine what type of triangle I have, I really need to know something about my side lengths, right? If it's a right triangle, then we know the Pythagorean theorem is going to hold up. A squared plus b squared equals c squared, where a, b, and c are the lengths of each side of the triangle, and c is the longest side. If it's isosceles, then what does that mean? Isosceles means that we're going to have two sides that have the same length, and then a third willy-nilly side. And then the scaling means that we have three different side lengths. So all of this is going to come down to what are the lengths of each side. To determine the length of each side, we're going to find the distance between each coordinate. So I'm going to start by just plotting these so we kind of have a visual of what's going on. Scoop that up. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, and -1. Okay, so we have 2, -7, so this point right here. We have -3, -1, so I'm just plotting points, -3, -1, and we have 7, -1, so right here. So we have three different side lengths. I have that one right there. I have the red side right there, and a third side. So I'm going to start first by using our distance formula to figure out what each of these lengths are. So I'm going to call the black, we'll call D1. The red, I'll call D2. And the blue-green color, we'll call D3. So we're going to find all of these. I don't know if y'all could hear my computer tripping out, but it happened. All right, so we're going to find the distance of each of these using the distance formula. So if you recall, the distance formula is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So this just means we're going to find the difference of the x values and square it, difference of the y values, square it, add those together, and take the square root. You can see in the learn section they do derive this for you. It comes from the Pythagorean theorem. I'm not going to do that here. We're just going to use it. So I want to find the length of this black side, so D1. So I need to know what are these two coordinates. We just plotted them. This is 7, -1. And this is -3, -1. So first, finding the difference between my x values, or the difference between my two x values. So my x values are -3 and 7. It doesn't matter the order that I write them in, as long as, just one second. Okay, I'm back. So, long story short, we need to find the distance between these 2 points so that I can know what the length of that side is. So let's say that this point, this will be our x1 and our y1 and our x2 and our y2. So we're literally just plugging these values into the formula. So I have the square root of x1 minus x2. So x1 we designated as -3, minus is part of the formula, x2 is 7, all of that squared, plus the same thing with the y values. So I'm going to have y1, which is -1, minus part of the formula, y2, which, is -1. There we go, squared. Okay, and now just a matter of simplifying. So -3 minus 7 gives us -10. And so we'll have -10 squared. And when I have a negative and a negative together, that forms a positive. So I have -1 plus 1, which actually gives me 0. Put all that back. All right, so -10 squared is actually positive 100, not 10. And 0 squared is just 0. So this ends up being the square root of 100, which is 10. So I know the length of this side is 10. Here's D1. All right, so now let's do the same thing. I'm gonna go a little bit quicker now, but we're gonna do the same thing for D2 and D3. Find all the side lengths. So this point down here is 2, -7. So D2 is going to be the square root of the difference of my x values. So let's do -3 minus, as part of the formula, 2 squared plus the difference of my y values. So y1 we'll say is -1 minus, as part of the formula, you can't see that, let's scoop that up, sorry about that. So -1 is my y1 minus, as part of the formula, and -7 will be my y2. And again, we're just going to simplify. -3 minus 2 is -5, and it's -5 squared, so -5 times -5 gives me positive 25. Be careful if you're using a calculator or anything like that. Put your -5, I'm going to write it over here, put your -5 inside of parentheses and then square it. Otherwise, your calculator will give you the wrong answer, believe it or not. So I'm going to... I don't want you to think that's part of the equation or anything. There we go. Okay. So -3 minus 2 is -5. -5 squared is 25 plus. Here we have that double negative again, so I have a positive. -1 plus 7 gives me positive 6, and 6 squared is 36. So this is the square root of 25 plus 36 gives me 61. So D2 is 61. And last one, real quick, D3. So we already have our two coordinates, and we just need to use the distance formula. So D3 is going to be the square root of the difference of my x values. So I'm going to have 2 minus 7 squared plus the difference of my y values. So -7 minus -1 squared. 2 minus 7 is -5, and -5 squared is 25, plus that double negative. So I have -7 plus 1 is -6. -6 squared is 36. So 25 plus 36 gives me the square root of 61. So D3 is the square root of 61. And so our side lengths are the square root of 61, the square root of 61, and 10. So if you come back up here to our descriptions, what type of triangle would we have? So our two side lengths are the same. This tells me that this is an isosceles triangle. We can double check that it's not a right triangle, so let's go ahead and exclude that real quick. I know it's not scaling because I have two side lengths that are the same, but I do want to double check that it's not a right triangle real quick. So we'll set up a squared plus b squared equals c squared. You can put in your calculator the square root of 61 and see that's going to be like 7 point something. So our longest side is 10. So we'll have the square root of 61 squared, there's my a squared, plus the square root of 61 squared, there's my b squared, equals c, this is my longest side, so 10 squared. So the square root of 61 squared gives me 61, plus the square root of 61 squared gives me 61, equals 10 squared, which is 100. 61 plus 61 gives me 122. And does that equal 100? I'm going to put little question marks here. We obviously see that it's not equal. 122 is not equal to 100, so we know for sure it's not a right triangle. So again, since these two side lengths, D2 and D3, are the same, then it has to be isosceles. Pretty sure that's how you spell that. So I know it is an isosceles triangle just by looking at the side lengths. And so the second part of this question asks me what the area of the triangle is. So I'm going to come back over here. It gives us a hint and says if it's isosceles, then we need to use the midpoint formula. Now, if you look at the triangle and you recall from, I don't know, geometry in high school, what the area of a triangle is. The area of a triangle is base times height divided by 2, right? So if I cut this in half right here, then I'll know what the height of the triangle is. This length here tells me the base, and then I can multiply those together and divide it by 2. All right, so we do need to know what this midpoint is. If I know what this point is, then we can again use the distance formula, figure out what the height is, and then we can do base times height and divide that by 2. So let me get a new sheet of paper. So I'm just gonna rough sketch. This right here, and we already determined that the top, this will end up being my base. This is 10, that right there. And so if we use the midpoint formula between these two, figure out what this coordinate is, then I can use the distance formula, figure out what the height of that triangle is, and then we can figure out the area of it. So we're going to do the midpoint formula on these 2 points right here. And the midpoint formula, we're just finding the average of the x values and the average of the y values. So this point was -3, -1, and this one was 7, -1. So my midpoint is going to be, like I said, the average. So average, add them up, divide by 2. So the average of my x values, so I'm going to have -3 plus 7 divided by 2. And the average of my y values, so -1 plus -1 divided by 2. And we're just going to simplify that. -3 plus 7 is 4, and 4 divided by 2 is 2. -1 plus -1 is -2, and -2 divided by 2 is -1. So I know this point right here is 2, -1. So to find out what the height of this triangle is, I need to figure out what the distance of that is. And we know this point because we just did the midpoint. We know this point is 2, -1. And this is the third point of our triangle. And we knew that was 2, -7. So we can now do the distance formula to figure out what the height of the triangle is. This is a long problem. So distance formula, let's call that D4. We're going to find that height of my triangle. So D4 is going to be the square root of the difference of my x values. They both have 2, so this is going to be 2 minus 2. That minus is part of the formula. Squared plus the difference of my y values, so -1 minus -7. That minus is part of the formula. 2 minus 2 is 0, and 0 squared is just 0. Plus, here's that double negative again. -1 plus 7 is 6. 6 squared is 36. So we have 0 plus 36 is 36, and the square root of 36 is 6. Whew. All right, so what that tells us is the height of my triangle is 6, the base is 10. So to get the area, again, we'll do base times height divided by 2. The base is the length of this this side right here, so this is 10. The height we determined to be 6 all over 2. So we have 10 times 6 is 60 over 2, and we get 30. There we go.